Okay, Kiara, I've got you. And Asia Williams. Okay, got you. Lavender. Let's see. Lavender C, I've got you. And Deja Monroe, I've got you. Um, and let's see. Let's see. York, he'd come in a little bit later, but I did see him earlier. Cassidy. Um, Sanders. Yep, got you. All right. So, okay. So let's continue. When the others come back on, I'll let them back in too. Okay, this is where we are. So we're saying that the existence of an inverse function, a function has an inverse function if and only if it is 1 to 1. Well, what does if and only if mean? It means 1 to 1. If something is 1 to 1, it's a function. If a function, so basically, if a function passes the horizontal line test, let's say, then it's 1 to 1. And if its function is 1 to 1, if it passes the horizontal line test. So if and if means it goes backwards and forwards. It's true either way. If our function f is strictly monotonic, meaning it's either strictly increases or strictly decreases through the entire domain, then it is 1 to 1 and therefore has an inverse. So a function has to be 1 to 1 in order for it. It has to be monotonic. It has to be 1 to 1. The function has to be monotonic, has to be 1 to 1 in order for us to be able to get an inverse. If it's not, then we have to either place a restriction on it, or we just have to say it does not have an inverse. Okay, so a lot of times in like trig functions, you'll see when you went through trig and graph trig functions, you had to put a restriction on it, domain and range, in order for you to be able to apply an inverse. Okay, so let's take a look at some problems here. In exercises 17 through 24, use a graphing utility to graph the function and use the horizontal line test to determine whether the function is 1 to 1 on the entire domain. Okay, so if we look at and we're going to look at problem number 18. 1 minus x cubed. So here's our calculator. Clear this. Clear it. Okay, so we're going to put in 1 minus x and then cubed and hit zoom and 6. And there we go. So you can see that it's monotonic because it decreases the whole time. And if we were to apply a horizontal line test, we could see that it would pass the horizontal line test. So it is 1 to 1, and we can't, that means we can get an inverse to this function. Okay, let's take a look at another problem, such as problem number 24. So we're going to put a natural log of x squared. All right, so we go back to our, clear that, go back up here to y1, and we're going to put in here natural log, and then x squared. And I always like to close the parentheses there. And we go back to zoom and 6 again. And so can we say that this function is monotonic? Hence 1 to 1. Well, all we have to do is look at see if does it pass the horizontal line test. If we put this paper clip for a horizontal line, does it pass the horizontal line test? Well,
Yes.
it does.
Oh no.
It doesn't, right? Because the horizontal line goes through 2 points, not just one. So it's not monotonic because it decreases and then it increases. So monotonic means it either decreases through the whole domain or it increases through the whole domain. So it's not 1 to 1, it's not monotonic, it's not 1 to 1. So therefore we cannot get an inverse. We would have to place a restriction on this. We would have to say for x is greater than or equal to 0, and then we would look at just the positive numbers for x, and then we could say it would be. But the way it is right now, it is not 1 to 1. Okay? Questions there. All right, so that's a good example. Those are good examples of what is 1 to 1 and what is not. Okay, so we'll put this away for a moment. We'll come back to it again. And now we get to the end, to the last objective here. And this is theorem 5.9 in your book, the derivative of an inverse function. Let f be a function that is differentiable. Okay, so that means it's 1 to 1, right? On interval I. If f has an inverse function g, then g differentiates at any x. Now, why the book uses f and g as inverses, why not just inverse? To me, it just makes a lot more sense. So the derivative of our inverse is equal to 1 over the derivative f of g. So in that case, that's the same thing as if we rewrote this as g is equal to the inverse function for f. Okay, so therefore g prime, or g prime rather, g prime is equal to f, the inverse of f of x, the derivative of the inverse. Okay, so when they say that g prime, or the derivative of g, is equal to 1 over the derivative of f composed with g, what they really mean is the inverse. Now, why they didn't just come out and just write it like this, to me, this just makes so much more sense, is 1 over f times its the derivative of f is f inverse x, like that. Okay, so where f prime and g are not equal to 0, because if they were, then you would have undefined here, right? Okay, so let's see how we're doing. All right, so let's take a look at this problem here, example 5. And I would recommend that you go back over this example and look at it again later. So this is example 5. And here we're saying let f of x equal to 1 over 4 x cubed plus x minus 1. Okay, and we're saying here that a equals 3. Well, we want to know what is the inverse when x is 3. So that means that if we had the function f of a, not a good idea to use, f of b, let's say, equal to a, then the inverse f of a equals to b. Okay, So because remember way back in the beginning when we switched the x and the y coordinates, well, what is the x for original function is comes out as y, right? Well, that's the y you for the inverse is the x. So the x and the y coordinates are switched. So what we're saying here is that this a is 3, but we don't know what that is. But that 3 is the y coordinate. So we would have to find what x is. Well, you can do that by saying, all right, we're saying that f of x equal to 3. So we can put 3 in place of f of x equal to 1/4 x cubed plus x minus 1. And so if we applied plus 1 to both sides, right, we get 4 equal to 1/4 x cubed plus x. Okay, and so actually we could just subtract 4 here, move it back over, so that now we have 0 equals to 1/4 x cubed plus x minus 4. So how do we find what x is from here? Well, if we can find that x-intercept, right, then we can find x. So we go ahead and we put this in our calculator, and we put in here, you can use 1/4 or 0.25. No, we'll just use 1/4. 1/4 x cubed plus x minus 4. Oops, I didn't want to do that. Okay, so I have to hit the right arrow to get out of the exponent. 1/4 x cubed plus x minus 4. And if we go to the second and table, okay, well, another way we can do it is just go to graph. And we see here that if we go to second and calc and 2 for 0, left bound, and then we have to go to right bound above it, hit enter one more time, we get 2. So that means that our x is 2. So f of 2 will equal 3. So if we put 2 in here, right, if we come back here and put 2 in, so let's do that. If we put in f of 2 in there, we get 1/4 2 cubed plus 2 minus 1. We get 1/4. 2 cubed is 8 plus 2 minus 1. 4 and 8 is 2. So this is 2 plus 2 minus 1. We get 3. So we're saying f of 2 equal 3. And so that means the inverse of that, f of 3 equals 2. Okay, so from here, we know that, let me get my other board. From here, we can say that G prime, the x, since G prime x is equal to 1 over f prime G of x, okay, then we can say that that's the same thing as if we said the inverse of x equal to 1 over f prime f inverse of x. So that means that the inverse of 3 is going to be 1 over the derivative of our inverse function of 3. So we need to find what the derivative for f is. So here's f of x. We said was 1/4 x cubed plus x minus 1. And so the derivative of that would be 1/4. Bring the 3 down. 3 minus 1 would be x squared. And this is 1 minus 1 is just 1. And then the constant goes to 0. So the derivative is going to be 3 over 4 x squared plus 1. So if we put in here, so what we're saying here is that if from here we can put in so we want to find what f of 2 is. So we put in 3 over 4, 2 squared plus 1, and we get 3 over 4. 2 squared is 4 plus 1. The 4's cancel, and we get 3 plus 1 is 4. So from that, we can say that f, our inverse of 3 is equal to 1 over f prime. We said, so this would be basically f of our inverse 3 is basically going to be, since we said that this is 2, if 2, 1 over is the same thing as f prime of 2. And so f prime of 2 is that we said was 4. So this would be 1 over 4, and that's our answer. Okay. So we're out of time now. We'll do a couple of more of these tomorrow before we continue on, and kind of get some more practice on that. All righty. So it looks like we didn't get to the other lesson, which is okay. No problem with that. All righty. So this is what I have on the attendance. Blackman, you're here. Let's see, I got Blackman, Lavender, Kiara, Shatia, Deasia, Perkison. Perkison here? I don't hear Perkison. Okay. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, so York, Asia, Thaddeus. Oh, Thaddeus is not here. Smith is here, not Thaddeus.
Did you get Williams?
Williams, yeah, I got Williams. I got Williams, York, Ashira, Smith, Cassidy, Janae, Rosa, not Perkinson, Deasia, Shatia, Humbert, Cushman, and Blackman. Okay. So we'll continue this tomorrow. And we'll get more practice on it. It'll make more sense tomorrow. All right. This one, example 5, is a more difficult problem. We're going to actually, for the homework, the ones on the homework are much easier. And so we'll go over some of those. All right. Okay. So have a good day. Don't worry about this problem. It's actually much easier than it looks. And we'll do some more of those tomorrow. All right. Have a good day.
Dr. Jennings,
Yes.
you remember we went over. You remember when we went over the essay?
Oh, we're not going over the second one.
I know. I'm talking about yesterday.
Oh yeah.
I would just let you know it was a whole different topic.
Well, no, the one that we went over, I believe that was the first essay.
That was the first one.
The first with the fine and tangent line.
Oh yeah.
Yeah.
Because the new one is the probability.
So the second essay, if y'all are have any more questions, you can hang around. If not, we'll see you tomorrow. You can go ahead and go. But let me see the second essay. I have it here. Let's see. Must be used as no other problem can be accepted. Find the points of, okay. Yeah, the second essay, find the points of inflection. So
I know, but online it says probability of the 52 cards.
Okay, I'll definitely check on that. Thank you.
You're welcome. That's why I was like,
course.
Yes.
That goes to a different, that goes, actually, that's for 134. So, all right, yeah, I'll definitely check on that. And
Okay.
I'll fix that. Thank you very much for pointing that out.
You're welcome. Thank you.
Okay, have a good day.